think about the things y'all tell me sometimes. Okay, so.
But what I love about that, what you were just showing, is that's how most of us were taught to multiply and divide. It was not like there was any reasoning behind it. It's like, here, you divide this into this, and you carry this, and it wasn't like, this is why. It was like, this is just the algorithm, and everyone just follows it, you know? So.
Yeah, it's like more rote memorization, and it's really kind of a bad way to learn because you're learning from authority. You're learning to reason from authority. It's not like you're seeing it for yourself. You're like, this is true because my professor is telling me. Like, you're gonna see me for what, this class, and then for the rest of your life, if you want to avoid me, you probably can, right? Like, I'm as big or as little as you want to let me be in your life, basically, right? I hope you don't learn this stuff for me or learn this stuff because, like, I'm saying it. Like, I hope you learn this stuff for yourself to some degree. And I hope you understand why it's true, right? Not just I'm saying it, so it's true. I think that's one of the, like, the more appealing the most appealing probably aspects to math is that, like, you can sort of see it for yourself. You don't have to trust me.
But also, I think asking students to discover things that it took, you know, geniuses millions of years to come up with is asking a whole lot. Because I've seen a lot of discovery type classes where I'm like, really? You want them to discover that in an hour when it took, you know, Aristotle?
Yeah. You gotta
yeah.
Open up the roadway, so to speak.
Right.
Guide them with the questions, but
okay, and before we get started, Matt, can I just say a couple things?
Sure.
So I know some of y'all probably have questions over that homework, and I wrote to y'all to ask Matt about them. I think we'll have time today to if you want to get him to go over the homework from last night, the written work, because a lot of y'all didn't do it right or well. And if we don't have time, we can stay after class or whatever and go over whatever you want with it. Also, I'm taking a course right now on teaching and learning. And so they're asking you to do an evaluation of me. And if you will, I would appreciate it. It'll be on Blackboard under, I think it's under evaluations. It's like in the blue bar further down on the list. You'll be able to see it. So, okay, that's all I have to say.
Okay, I'm gonna print this thing out then. The 6-5 homework, is that what you're talking about? They did the 6-5 homework last night, right?
Yes, the written homework. I think lots of misconceptions on that.
Okay, so I want y'all to spend a little bit of time to do these, the exponents 1 and 2, and then we will go over them shortly. Like I feel like for the most part, hopefully you're getting this, but I feel like we can kind of do these in one sort of swoop. These are just kind of like properties. I guess there's a few ways to get them wrong, but for the most part, hopefully, we're getting these things right. Projectile motion.
So we're just starting with like A, 1A?
Yeah, I was hoping y'all just go through all these, hopefully.
Oh.
One and two. I was gonna give you like 5 minutes.
Okay.
Probably start on A. Or
Okay,
start
give me a
on
second.
one. But they shouldn't take you too horribly long to do these, hopefully. Those last four are pretty much just do you know that property kind of sort of thing. They're not even a lot of like crunching, you know. Okay, so part A, we have 3/9. Instead of 3/9, what is that going to become? So how would you simplify 3/9?
1/3.
Yeah, so we're dividing both by 3. And then we have z to the 5th on top. Well, what's going to happen to that thing?
Subtract 1, it'll be z to the 4th.
Yeah, z to the 4th on top. And we still have a y on bottom. So you wrote this is good. You don't have to write the 1, though. Probably won't write the 1. So z to the 4th over 3y. All right. So what'd y'all do on this one? What's the exponent on this guy?
1.
I think someone said it. There should be a 1 exponent there. Did y'all combine the x's and then do the to the 3rd, or did y'all do the to the 3rd and then combine the x's? I think it's the next option, ain't it? There's 2 ways to go about it. That's all I'm asking.
I did the exponent first and then combined everything after.
Okay, so we can do it. The 12th. And 2 to the 3rd is 8. X and 3. 15. So the important thing to remember on this one is that if we have a constant number, it is getting raised to that exponent. It's not getting multiplied, right? But the exponents get multiplied. So there are two different sort of operations happening. Okay, part C. So if you didn't know how to do this, this one is not a big power. You could probably write this thing out twice. Well, what should this look like?
Which one is it? C?
Yeah, see? So what's happening to 7?
49.
It'd be 49. What's happening to
Z to the 10th.
And then on the bottom, what's happening to this y? I have my y.
To the second.
Yep, second. So 49 z to the 10th y squared.
Yeah, I don't think you can do anything else with it.
That's it. You got a constant, you got a z variable, and you got a y variable. That's about it. Those aren't going to have anything in common. So C, D, E, and F are sort of like, do you understand this thing that's happening here? 3x to the 0.
Equals 1.
X to the 0 would be 1, and then you have to multiply it by 3. So overall, it should be what, 3?
Oh, I see. So the X is 1 and then you multiply that by 3.
Yes.
Oh, okay.
Yeah. So when you look at this, it doesn't really say it there, but the 0 is the exponent for the x. If we wanted to, we could put a 1 exponent on that 3, but there is a 3 there.
Okay.
Now this one should be what?
Well, that because of the parentheses, E is 1.
This entire
Huh.
We have a 3 to the 0, then we have an x to the 0. Minus 5x squared. And minus 5 squared. Or a minus 5 squared. So how do F and G differ? They're both 25. Negative 1. Which one's which?
The parentheses 1 has to be the positive because the negative is included in the operation.
Yep. And then this one is the negative, because what we're doing is we're squaring the 5 first, and then we're tacking on the negative. You could read probably something like that to indicate the square is happening first, if you really wanted to. Talking about minus 1. Questions about this? Are we getting these exponent properties, hopefully? These will pop up a few times. Okay, so this one, A, you have to be careful with maybe your negative signs, but this should be A to the what power? And then what's the operation here?
Okay, so we're skipping over 2?
No, I'm doing 2 right now.
Oh. It looked like you were doing 3. Sorry.
No. So how do I do this power? What's the operation?
Subtract.
Yeah, so I have to subtract, but I have to subtract a negative. So what should this be overall?
Positive 9.
Yeah, positive 9. What about B? How am I doing B?
But I can ask something.
Yeah.
Even though it simplifies to a to the positive 9, initially the positive 9 would be at the top, right? Before
Yeah,
we
you could say
simplify it
A.
down.
You could say this is over 1. Is that what you're asking?
Right. So you're not bringing it down is what I'm trying to get at.
No, it's not going into a denominator.
It goes at the top. Okay.
Yeah, things that are like whole numbers and things always kind of go towards the top, right? We can always put them over 1. They're always going to be in the numerator. Okay, so part B. Does y to the minus 6 y2? Same thing. What's my operation? Have y. I start with y to the minus 6.
Right. So that would be +2, which would make it a -4.
Yep, y to the minus 4. Typically, we don't write y to the minus 4. I'm going to write what?
1 over y to the 4th.
Yeah, that's it. I'm going to flip it over 1. This thing is over 1. If you really want to do all the things, put the denominator down there. If it's negative, we got to flip it about the division bar. Okay, so C is a little more complicated. Not a lot. What there's not a lot you can really do with C. What can you do with C?
Make a negative exponent of the denominator.
Yeah, flip this y to the minus 1 down.
Real quick, before we continue forward, on some of these, we don't really have to show any work, even though between you and Mrs. Watson, you both grade on work. If we just write an answer, because that's really all that can be done on some of these questions, will points be taken off?
So like on something like this one, there's not a lot of work to do. On these, there's not like a lot of work to do. But like if you're doing like an elaborate word problem and it's like you have a lot of work that you should be showing, right? And you don't show it, and then like you just give me this answer that's correct and it's coming out of nowhere. To me, that looks like almost more highly suspicious than you just getting something wrong. Like,
All right, just checking.
like what is this kid doing? Is he doing this legitimately, right? And you're like, where's he getting this
No,
answer?
I see what you mean. I was just asking because like I spend most of my time trying to put work in so that way you guys know that I'm doing this correctly, but it's like how am I supposed to show what can be done in one step?
Yeah, a lot of this stuff is like these exponent stuffs is just like a single rule, like this stuff, D, E, F, G.
Yeah.
There's no work you can show for that, really. Like I was like, or the work is pretty like minimal for the most part. If you just gave me a solution for like D, E, F, G, and if you like you understand it, then good, right?
All right, appreciate it.
So this stuff, it doesn't have a lot of work to show for it, I would say. So I would like typically what I'd say is like show your work, cover your own butt, because if you get something wrong, I don't know, you usually get more points if you don't show anything. Okay, so we want to just convert it to scientific notation. So my decimal should go where?
Between the 1 and the 3.
Right there between the 1 and 3. So I'm counting zeros. I'm moving 8 spaces. Is that correct?
Space to the left.
Okay. I'm moving 8 spaces. So this is 1.5. So that should hopefully kind of fill out itself. Then we have to ask ourselves, what's the sign on this guy?
Isn't it like a negative 8 that you're going to the left?
It is a negative 8. That's the thing that's the task.
All right, good.
That should be negative. So if it's a large number, it would be positive. This is a really small number, it should be negative. We have another scientific. In scientific. How do I multiply these in scientific notation?
You just move the decimal back to the left, the number of the exponent.
Are you saying convert this to standard? Is that what you're saying?
Oh, sorry, we're talking about the next question. My bad.
Yeah. How do I multiply things in scientific notation? There's a sort of like shorthand way to do it. Do you remember? Probably gonna need a calculator for the first part. Or maybe not. It's not too big.
So first you
Yes.
multiply the two leading numbers by each other.
And that gives me 13.8.
Right, and then you take the two powers of the two 10 powers and multiply those.
What's the operation here? So this exponent's two exponents you multiplied. This is like bases. What's the rule of like bases?
Yeah, well, I mean, you're multiplying them, but you're actually adding together the
We're adding the
numbers.
exponents.
Okay, yes. You're probably saying the right thing then.
Yeah.
We're adding the exponents there.
Right, so that's negative 12.
Yep.
I got
So this
11.
is 13.8 times minus 12.
Okay, so then that's it, I guess.
Yeah, this is pretty close. We should convert it to 1.38. And if we do that, have to think a little bit.
Oh,
Yeah, it should be really
So-
move that decimal.
then you subtract another power, and so make it negative 13 then, right?
Mm.
I got 11.
This is going up down. You said it right. Minus 11. I have to add one to it.
Mhm.
But I thought if we're adding one, it's gonna go to the right, isn't it?
Yes.
So, okay, when we go right, we're subtracting. When we're going left, we're adding.
This one went left, so this one has to go right.
Okay.
Because this is the same number. If one goes up, the other one's gonna go down. Okay. And then dividing by scientific notation.
What was that, 13.8?
Yeah, 13.8
Yeah.
times 10 to the minus 12. And 1.38 times 10 to the minus 11. And now we want to look at this thing, 2 over 4. So this thing, how do I do this scientific notation?
Same as the multiplication. You do the notation and the constants separate from each other.
Yeah, so 2 over 4 is going to be a half, that's 0.5. Times 10 to the minus 15 minus a minus 9. So I'm subtracting my exponents. So this is like a half times what, 10 minus 15 plus 9 is going to give me what, 6. All right. I'm doing too many things in my head. Yes, minus 6. And we have a same sort of like issue here. We don't want the 0.5, probably the 5.0. Down. Are we getting these scientific notation ones hopefully? This is from the Earth to the Sun is approximately 9.28 times 10 to the 7th miles. There are 550, 20, 80 feet in a mile. Express the distance from the Earth to the Sun in feet using scientific notation. round the base to 3 decimal places. Oh man, this is like what I'm doing in my other class right now. We want to convert miles to feet. This isn't the best thing, is it? Yeah. So we're going from big to small, or small to big. Where are we going? Big to small. Do y'all know the rule?
Nope.
Big to small, multiply all. Small to big, divide the pig. Something like that. So we're going from big miles to small feet. We should be multiplying, I believe. Doing in my other class, we can think about this thing one. Indicator that there are 520, 52, 80 feet. If we want to simplify out miles, there's this cross simplification that we can do. We go miles to feet. That actually tells us this is known as like unit analysis. If you take a science class, this might be really beneficial. But there are 5280. So all this thing is over here is just a big fancy one because these things are equal. Have the same thing over itself. So this will also kind of sort of tell you if you set things up with unit analysis, which we didn't really teach in this class. But this will also tell you that we should be multiplying these numbers. So I'm not really trying to spend all day on this word problem, to be honest. But that tells you we should be multiplying these numbers. Yeah, this one's okay, I guess. I think what they probably want me to do is probably convert this to scientific notation first, if I were to take a guess. If I'm being honest, if I had my calculator and I had my calculator during a test, like I would just probably, I'd probably convert it to scientific notation because it has that option on there. But 9.285, we've done one like this already. It's not super unique. So if we multiply the two numbers, I'm getting 48.88, somewhere around there. Something in feet. And then we have to do that thing 2.89 or something. But I'm going 4.88. I move this left one. So this is getting smaller. This one has to get larger. So there's probably a few ways you could do that one. You could probably just multiply by the 5280 by the 9.
Yeah, that's what I was gonna ask. Yeah.
You could do that way as well. There's a few different ways. There's not really one sort of correct way. You should get the same thing. Yeah.
So when you convert it to scientific, it's just making it easier working with smaller numbers and stuff initially.
Yeah. And this one's not too big because it's in the thousands, right? But when you get to things with like here with 11 decimal places or whatever, you don't want to be writing out 11 numbers, right? Like,
right.
That's crazy. Too much work. Okay. So list the degree and coefficient of each term and state the degree of the polynomial. So what's the degree of this first term? Minus 3x to the 7th y. We didn't talk too much about it, but I did kind of briefly mention it. If we have two variables, what do we do to figure out the degree? Like we got x to the 7th, y to the 1st. What's the degree of that term?
You add all the exponents from each term, right?
Yeah, that's exactly it. 7 plus 1 is degree 8. And what's the coefficient on that thing? It's-
-3.
Yeah, it's the number that's not a variable. Let's degree with a coefficient of -3. This one is a degree of 5 and 2 will give me 7, and the coefficient there is what?
-1.8.
Yep, that's it. And the next one is a degree of 10, 6 and 4. And what's the coefficient there? Ooh.
1.
And this is the degree of. We're out of room over here. What's the degree of -2y?
1.
Yeah, it's a degree 1. The thing there that's not the y, the 2. And the last thing, what's the degree of a constant?
0.
0. And the coefficient there should be
5.
yeah. And if you really want, you can put an extra y there and put it to the 0 power. X to the 0 is just going to be a big fancy 1. It's not doing anything, right? So you can think
How come the 2 isn't a negative?
because it should absolutely be right. Sorry.
Oh,
That one, is that what you're talking
okay.
about?
Yeah.
Should
Okay.
be. My bad.
No, I thought I was wrong. Okay.
No.
Um,
And then the last thing they ask is for the degree of the polynomial. What's the degree of the polynomial?
I guess if you add them all up here,
Mm,
you have to solve it first. I mean,
no, the degree is always which degree?
simplify it.
The highest
Polynomial.
Yeah.
degree of the exponents. So 10.
And you're the longest degree here. So this is the poly. Let's the degree of determinant, and let's take the degree of the polynomial is the 10th. If they wanted the leading coefficient, what would the leading coefficient be?
-3.
Ah, careful. It's not written in the right way. It should be the 1. When they say leading, they mean for it to be written in descending order. So maybe that was a bit tricky. We should have really put this term first to be written in descending order. And then the leading coefficient would have been 1. Okay. Simplify and write in descending order of the powers of A. Okay, so what's the largest power of A you see there?
A to the third. There's
Hopefully that.
2 of those.
And so we should put those together, hopefully. And what should those calculate to?
-6 A
Uh-huh.
to the third.
So if we don't see it, we can also B squared attached to that thing.
But I mean, wouldn't the B squared interfere with the adding of the A to the third?
No, because when you do this, when you look for like terms, they have to have all the exponents the same, right?
Right.
And all the things. So what we're essentially doing is we're pulling this out. -7A to the third and 1A to the third B.
Right.
What allows us to do this, we can pull that out as a common factor, and what we're actually doing is just
Yeah, but I'm saying, let's say that the B squared wasn't there on the end. Wouldn't you not be able to put those together?
then they wouldn't be like terms. Yeah, they all have
Right.
to be the
Oh,
same.
okay.
Yep.
Okay.
So -6A to the third B squared. And what comes next?
Combining the AB squared terms.
to the first.
All right.
I do want to do that, but like before you do that, if we're doing this in descending powers of a, the next descending power should be
A squared B. That's
the
right.
a squared, yeah. Minus a squared b, and then do what Hunter said. Combine those last two terms. So if we do plus 13 minus 5, what is that going to give us? Are there questions about this? So we have to make sure that the terms are exactly the same, that all the variables and all the exponents are exactly the same. But this is just a problem about combining like terms, basically, right? If there's anything like y'all are not understanding today, y'all are awfully quiet. There's like a few of y'all, but y'all are kind of scaring me because there's a test tomorrow.
Okay.
It's coming. But if there's anything you're not understanding, like I have office hours today, you can come by office hours. We can go over anything if you want to request to go over it instead of going over this. Whatever y'all want to go over. Like this is your test tomorrow. This is your time to study. Like I don't know. I do number 9.
Sorry, I was gonna. So like the final way that we're gonna write number 8 is because I'm thinking of starting to do the AC method or something on number 8, like. Or something, you know what I mean?
This one they're just asking you to simplify and write in descending powers. So it doesn't say
So
anything.
we're not gonna do all that.
It doesn't say anything about factoring. It just says to write it in descending order, which means,
Okay.
which typically means in an expanded form when they say descending powers.
AB squared. Wait.
Oh.
Oh, there's 2 AB squareds. I didn't even see that. Okay. Yeah, you're right.
Yeah.
I gotta be careful here. Yeah, so I think the wording on these problems is really important because they look very similar to each other. You have to read the wording of it, you know, to actually figure out what it's saying.
Yep.
Because if I just look at the numbers, I mean, I'm starting to think of all kinds of things and to do.
So how does this one differ? I guess it's not all in one expanded form. They put a little sign in there, but this is pretty much the same thing. There's just one little thing we have to do first, right? So if I was doing this, I would do 3x squared y plus 2x y minus 5x. And then what's the approach with that negative sign?
Distribute it to the second expression.
So everything gets split. So minus x squared y plus x squared y minus 3x should be plus x, and plus 2 should not be minus 2. And I would do this in descending powers of x, probably, is what I'd probably pick. So if we want to do descending powers of x, I think the highest thing I see there is an x squared. And so what I'd do is I'd look along for another x squared term.
Yeah, this one is actually a like term to one further down. X squared y.
So I don't see a number here. What should I put here?
Well, I mean, that's just one, so.
Yeah. So this should be what? 3 plus 1?
Right, 4xy squared. Y.
Yep.
Oh. Mhm. Yeah.
Did I do this right? Copy down. X plus 1, yeah.
5 plus 3, that's negative 2x.
And then now we have like some options because there's 2 different terms of the x in there.
Yeah, I just start scanning for whatever I can find.
So I see like this thing. And I combine any of those. What can I combine?
The negative 5x and the 3x.
This one and this one I like. that other guy is not like the other two. That is not a like term. I think he's all by himself. -5 and +3 is going to give me a -2x. And then the only other thing I see there that I haven't written down yet is the -2, I believe. So we're looking for like terms. Like terms, they all have to have the same exponent. All your variables have to have the same exponent. Are y'all getting this? Multiplying things, expanding things. What do we got? I feel like we need to start getting to some factoring or something pretty soon.
Okay. Did you want to skip over like?
Yeah, I mean,
Well,
this is okay.
well-
Y'all should know how to do distribution, but in all honesty, like, you really need to do factoring, and like we can do distribution to check our factoring. So I feel like it would do factoring. We kind of hit two birds with one stone sort of thing. More so than just focusing on distribution. And to be honest, like most people, they have a lot better time with distribution than they do factoring. We need to get on to factoring. So how do we factor these things?
We're talking about 12, right? Okay.
Yeah, 12A, B, C.
Yeah, there's a lot. Which one did you want to start?
Start with like A. Let's do
Okay.
two terms to 4 terms. I don't know, 3 terms.
Okay, and then D. And then K.
Is there one? Yeah, let's do F. That's the one I want to look at too. ADF.
Okay.
1, 2, 3.
Plus
4.
I think that's it. That's a big one.
So what about A? What can we do with A?
I only got one step into that one.
Yeah,
It's
it's
on the
not a
greatest
lot.
common
So if you're not
factor,
getting
yeah.
a lot out of that one, you might be doing it correctly. So what can we do with this? What's the first thing you should always do when you factor something?
On the greatest common factor,
Yeah, what's your GCF here?
I got 2x squared.
That's perfect. 2x squared. I put my 2x squared down. I factor that out. And what am I left with?
3 squared. No, 3 and adds 2 to the power of 2
Yeah, 3x. And you said what? Plus?
plus 4.
That's it. That's it.
No, it's 4x.
Oh yeah, there's an X in there. And if you want to check, it doesn't make sure it's fully factored, but you can always try distribution, right?
Is this
Oh.
A?
This, wait.
Uh,
Woo, what am I doing? You tell me 2x squared. Is that what you're saying? I'm sorry.
Um,
And it should leave me with 3x plus 4.
oh,
It both had an x on it, right?
uh,
I think it's what you said, and I don't think I heard you for some reason. Or I heard you, but it didn't process. I'm sorry.
3.
Okay, so what are we doing on part D? What's the approach there? There's probably a few ways you can do this, but there's probably one way that makes it easier.
I would do for D.
Yeah, for part D.
I would do 6 or -6. And X over 3.
How are you factoring that? Are you factoring it as a GCF? Is that what you're saying?
I'm factoring as grouping.
As grouping. So yeah, we do want to eventually do grouping on this, but before we do grouping, the first thing that you should always really kind of check for is what?
GCF.
Yeah, GCF. And I think these are all divisible by 3 is what it looks like. 3, 6, 24, and 12. So a lot of times if you look at like the smallest number there, it might give you a good indicator as to what they're all divisible by. So I
Wouldn't
think,
it be -3?
yeah, so you want to pull out a -3. You also want to pull out a
X.
x. And so we pull out a -3. X to the third. Minus
X.
x squared on that thing. So I'm dividing everything by a -3. -3x. I know I might be going a little fast over some stuff, but we've gone over it a few times. Hopefully you can see like what I'm doing. This is +3. And what is this? 12. And x over x. I don't have any more x's on there. Okay. So now I have this. Now what am I going to do with this? What's my approach here? Yeah, you said it earlier. Capture by grouping.
yeah, but there's another GCF there.
Is it?
2x squared.
No, the 1x.
So there's no 2's on this guy, and there's no x's on this guy.
Oh, okay, so if we find a GCF, we have to do the entire thing again.
Yes. The
Okay, I was
GCF
just-
has to come out of the entire thing. When we do grouping, you like you're saying, we can pull it out of these two things, right? So between
Oh, but that's what I mean, though.
between 2 and 8, I can pull out a 2, and between
Yeah.
x squared and x to the third, I can pull out a x to the
X
what
squared.
power? Yeah, an x squared.
Yeah.
And then similarly with what? X minus 4 is what they
Yeah.
with. What about this
Then
thing?
the other one, there's no GCF.
So what should I pull out?
By the way, it is. I think,
Just one.
You should always pull out that one, right?
I think
Always pull out a positive.
I think the 1x is a negative, I think. Oh, but you pulled out a -3.
Yes, and so that flips the
Okay.
sign.
So this is all flipped here. Okay, I didn't see that. So whenever we have negative, we should always pull out that negative.
Yeah, when it leads with a negative, you pull out the negative.
Is that a rule or do you?
Yeah, it's just in general, it's just the way it works out.
Okay, so it's not like you get to choose to do it or not.
Nah, you should really do it.
You should do that, okay?
Yes.
And the reason why is because the negative 3x squared, is that the reason why we pulled out a negative 3?
Because
Because-
of the leading minus 6x to the 4.
Oh, the leading one. Okay, that was the
leading
rule.
one.
Okay, I remember now. Okay.
And if you want, you could, well, you're still gonna have to pull out the negative 3x, but you could throw this thing into a box. I'm doing it factored by grouping. A lot of times this +1 thing will mess people up, but if you put it in a box, it's a little more obvious. You have to put a number there. I don't know. It helps you with your structure to do the box. He says as he's not doing it, but this should go into 2 things now. I have 2 factors. One of them is what, and the other one's who. So what are my 2 factors?
2x squared plus 1.
And hopefully it's there twice is the x minus 4. Is that it?
No, you need to bring your negative 3x down.
Yes. Okay. So that is a factor by grouping with the GCF in the beginning, right? Okay. You got it. Okay. What about F? What does that look like? What's your
Perfect
process?
squares. Difference of perfect squares.
Yep.
Oh wait, you should look for GCF first. Yep.
For
there's nothing there.
GCF, but between 9 and 25, 9 is nothing but 3s, 5 is nothing but 5s. There's not going to be anything in there. That one is a constant and don't have no x's, so the no x's can get pulled out. So good point. We want to look for GCF, and there is none. This is a difference of squares. 9 is a square, 25 is a square, x squared is a square. So if I take the square root of 9x squared, what am I getting?
3x.
And if I take
5.
one of them's plus and one of them's minus. Now, are we done factoring this?
I believe so, yeah.
That's it. Yep. We all know how far to go. Those aren't always fully factored when you're done with them. Remember, sometimes we can hide difference of squares and difference of squares and stuff like that. Okay. 8x squared plus 20x minus 12. So the first thing you want to do is what?
Greatest common factor.
Greatest common factor. What is that here?
It's a 4.
Yeah. You can always like kind of guesstimate things too, right? You can take out 2, and then everything's still even. You can take out 4 total. And you can always kind of check right here if you pulled out your GCF, right? If there's anything in common, which there's not because we have 2, 3, and 5, you could always pull it out more and multiply it by the 4. But 4 is your GCF. Did I write that down? Yeah, that's correct. This is the problem now. What's the process to solve this? Or to factor this? Not solving.
AC method.
The AC method. So I'm looking for something that multiplies what? 5. 1 and 6. Has to be negative. So what are my magic numbers? I'm breaking that.
Is it the 2?
So they got to
Has
add
to be negative.
They got to add to positive 5, and one of them has to be negative.
Negative 1
6 and
and
negative 1, yeah.
Should be the ones. So this is, yeah, 6 can be a real tricky one because it's like 3 and 2 add to 5. No. Gotta have the right negative signs on these things. It is really tricky, huh? As I take this thing, I break this into you can use your box method if you prefer the box. You can throw this into a box. But drawing boxes takes a little bit more time than just drawing little brackets. So, yeah, I can take out X, this is 2X. I can take out
Is it 3?
yeah, we can take out a 3. Hopefully that leaves me with the same thing right over there, which is 2x minus 1. And if that's the case, then what? How can I factor this?
uh, 2x minus 1 and x plus 3.
Yep.
And bring down your 4.
And don't forget to bring down your G if you took one out. Absolutely. Oh, why are you calling me during class? Silence. Oh. Okay, so should we go over last night's homework probably? And then we can get back to
Yeah,
this.
go ahead, would you please?
That's not-
Yeah,
Some of the instructions were a little vague.
okay.
And anyone that wants to resubmit or submit it late, I'll totally take it.
So she's going to throw a ball from the top floor of her middle school. When she throws the ball from 48 feet above the ground, that's the function that they give. Of the ball above the ground as a function t. So they're giving us the projectile function. So t is time, h is the height of the ball. And we talked a little bit about this. Let me grab some more paper. But this thing looks sort of like an inverse parabola of some sort. And you're saying it starts at 48 feet. So what I'm kind of thinking in my head, she's starting at 48 feet. She's lobbing this thing up, and it's probably going like kerplunk. Here's, I guess, a ground down here. Time to hit the ground. This part, I really shouldn't have drawn anything left over here. Like, this part is the part of our model right here in the first quadrant. The times the ball will be 48 feet above the ground. So if it's a T, to be honest, you really don't have to know what the model looks like. You could just do this stuff like super rigorously, like through the symbolic sort of interpretation, right? It helps to know like what's happening here a little bit, probably. So how do I figure out when this thing is going to be 48 feet above the ground?
Set it equal to 0.
Ooh.
Now,
What is this telling me? What value is that giving me?
t
It's a what?
times the ball will be 48 feet on the ground. So height.
So they're asking you for t, they're giving you a height, right? So this is an
Right.
h. This is an h variable. So we have 48 and we want to plug it into where?
As the answer to your equation.
As the solution to this equation, as my h variable. So I'm plugging in 48 into my h. That's going to make this thing probably pretty simple to solve, to be honest.
Right.
Because the first thing we see is 48 on each side. The first step when you're solving an equation is to do what?
Or
Set one side equal to?
so subtract 48.
That's what we got. Subtract 48. This is going to give me 0. I have set one side equal to 0. Now the next thing to do is to factor and solve. So when I factor, the first thing I do when I factor is I look for a what?
GCF.
A GCF. This thing you should be able to find a GCF and it will make your life so much easier if you do it. I can pull out a
T.
a T. And if I pull out a minus 16T, what is that going to leave me with?
C minus 2.
T minus. And I know I have 0 written on the left side, which is kind of weird for me. But it's the same thing as we had previously. We have this thing. Is it fully factored? I guess is my next question.
No. Well, I mean, yeah, it is, but you still gotta find T.
Yeah, okay, so it's fully factored. We want to find T. What's the first thing we set equal? 0. And that first factor minus 16T.
T minus 2 equals 0.
Yeah. And so this is giving me, I can divide by minus anything
Nothing.
is just 0. That's giving me the 0. This thing, when I add to, it's going to give me T equals 2. Ooh, a lot of people forgot that.
Oh,
That guy right there, T equals 0. That is giving you a solution, so you got to be careful with that.
That has to be added when we do finally solve for T, right? So because 2 seconds, even though it's asking for the time, you gotta include the T equals 0.
You have to include the 0 seconds.
You have to say that again, you're breaking in and out.
So we got to include the 0 seconds because when we think about this problem, they ask when is it going to be at 48 feet? It's going to be at 48 feet at both the 0 and 2. She's starting out at 48 feet, so 0 seconds should be a solution.
yeah, if you just read the word problem, it's obvious that when she first throws the ball, it's at 0 seconds. So that actually makes sense.
Yeah.
All right.
Yeah.
Now, this is a bit of a different problem. Now we want to ask, when will the ball hit the ground? So what is this like saying hit the ground? Instead of saying hit the ground, I can say H is equal to
0.
0. And without like even solving this problem, I can already kind of tell you what my solutions are going to look like. One of them is going to be more than 2. The other one is probably going to be less than 0, which is probably something I'm going to have to reject. Okay. So we set this thing equal to 0 minus 6 plus 32. I want to know when this thing's going to hit the ground. And like I said, what's the first thing you should do when you solve something? Well, the first thing is to set one side equal to 0. But we have done that already. It's already there. So once one side is equal to 0, the next step is to factor this thing. When we factor this thing, what's the first step we want to do when we look for factoring?
For GCF.
For that GCF. And I think we can pull out a minus 16 from everything in here.
Yes.
And if we do that, that should leave me with what? T squared 2t plus what? 3?
I don't think that's how it works. Isn't it 1 over 3?
It should be 48 divided by 16, right?
That's right.
And now how are we going to factor t squared minus 2t minus 3? What's the approach here?
AC method.
AC method is the way we're gonna have to go. So we can do a multiplies to -3, adds to -2. So 1 and 3 are the two numbers. With the, I think the 3's gotta be the negative, huh? So should I do this the long way or the short way, I guess is the question.
-3.
You say about shortcuts.
So what is this gonna factor to?
T plus 1 and T minus 3.
Yeah, so we can actually jump straight to those factors if we want. If not, we can break up the middle term. Okay. So what are my solutions? How am I getting those? So either what or what?
T is equal to 0.
Yeah.
T plus 1 equals 0 or T minus 3 equals 0.
Either T plus 1 is 0 or T minus 3 is 0. If T plus 1 is 0, then T is going to be what?
-1.
1.
What kind of 1?
Negative.
Oh, the negative
Negative 1.
Yeah.
And this one, if T minus 3 is 0, then T is going to be equal to 3. So it asks us when will it hit the ground at -1 second and 3 seconds.
So
Uh-huh.
so I put 4 for my GCF, and I still got like T minus 1 and then T 3.
Yeah, you absolutely you get the same solution.
Would that still be right?
Yeah, as long as you solve it right. But there's something I'm hoping you'll tell me right now. If we look at these solutions, what can you tell me?
Well, time can't be negative, so really your answer is 3 seconds.
That's my solution. So don't give me the -1 second. So this is what we call like an extraneous solution. Is extra doesn't make sense. The realistic bounds on this problem don't allow that thing to happen, right? And that just happens to be like because our parabola model extends beyond the first quadrant, right? Basically, it extends beyond what we really need it to. Questions about this thing? Are we getting this now? Hopefully.
It's gonna take a little practice, but yeah, it's starting to make sense.
I'm guessing if I had to guess, I didn't look at the homework. I didn't grade it, but if I had to guess, y'all probably messed up on the setup with setting this thing equal to 0 and setting the other thing equal to 48. That was probably one of the things that was commonly missed.
Yep. Nailed it.
The setup is really kind of difficult on this thing, so. But they are valid questions to ask.
Real quick, there's gonna be one like this in tomorrow's test, correct?
Yeah, it might be. So HMT. This one, I don't want to give too much away, but this one should be like probably the easiest question on here.
Just asking like at what point in the second time did the height of the ball reach? So really, you can just refer to the graph on that one, or that. But you plug it in.
But just as many people miss this one as miss the other ones.
We're doing like plus 3. God, what is that? 16 and 48 is what? 64? Is that what this is? If so, you just tell me what's the height of the ball, and you tell me 64. You're like half answering my question. Put some units up on there. I think it's feet, right? I think, yeah. I know, like, Ooh, that might be something.
Oh, yeah, one
Go
second.
over. Do you know how to input functions into your calculator and stuff like that?
I only have a scientific calculator.
I could be doing it in the little app.
Yeah, I'm just trying to when I'm learning to solve my equations and stuff to not even rely on that because I'm afraid of it not working during my test.
Yeah.
So I don't want to get used to using it.
Yeah.
And I don't have a graphing calculator either.
Yeah, I'm kind of like wondering whether I should show this, but I kind of feel like maybe I should because there are people that are going into like going to have to take science classes and stuff, and this might save you like a bit of a headache. So if you want to do this, like y equals, we can actually plug stuff into the y equals into these calculators. So like minus 16, so negative 16, and I'm going to do x squared, and I'm going to do like what plus 32x. So I know the problem says t, but I'm doing y's and x's instead, so sue me. I don't know what to tell you. They're variables. We can use whatever we want, kind of. So I have this in my calculator. I don't want to type in anything anymore, so if I quit out of this thing, there is in variables. I've put it in my variables. So if I hit the variables and I scroll over to y variables, this is where my functions come in. I put it in my y1 function. So if I want to evaluate my y1 function at 1, oh, looky there. I can evaluate functions at certain values. The other thing you can do, this is not, like this might be hard if they gave us something like, you know, like, I want to say second enter. No, clear. No. It might be hard if they gave us something larger than 1, like if they gave us, where's my, it doesn't want to do it now. Okay. This app's a little wonky. But if I did something like 2.3, right? Or something that's like more complicated, I can get those numbers in between easier doing it this way. The other way you can also do it is if you're doing like a table or a graph. Ooh, let's do a table. I can do, there's 1 in 64. So there are a few ways if you know how to work your technology to get around these sorts of things and make your life a little bit easier. Anything else? Should I go over this one too, or should I let them do that? Yeah, do that one too. Okay. Okay, so what's the first thing I want to do if I solve a equation?
GCF.
Ooh, that's for factoring.
No,
Maybe
that's
add
the
24
24.
sides.
I heard like two different things at the same
Oh.
time. I don't know.
Sorry. The 24 y square.
Move this guy to the I'm hearing. So I got to subtract that guy over. Like the largest. The next thing zero. Don't forget your zero. We look at well, I'm giving you too much. So now what are we doing? We got our one side equal to 0. The next step is to do what?
Now you find the GCF.
Now we factor and find the GCF. So we look at 3, 24, and 48.
Goes in 3y.
I can pull out a 3 and I can
Or
pull out a y from everything. That's going to leave me with the y squared here minus, this is going to be 8 and a y plus, I can pull out 1 and 6 would be 48. And I think that's it. Oh man, I can almost guess what people did on this one.
I'll go ahead and say it. I did the AC method on this one.
One thing they didn't put it in the right order of exponent. That's one thing they did right off the bat, and then that messed it up from there. So.
Oh, they didn't put it in descending order, huh?
No.
This thing's got to be in descending order, especially if you want to try to do the AC method. Gotta be in descending order. AC method, it sounds like a good way to go about it. 16 is 116. 2 and 8, 4 and 4. So what are my magic numbers? That's a horribly drawn 4.
-4, -4.
-4, -4.
Yeah.
And if you want, you can divide this thing like y squared minus 4y minus 4y plus 16. You can do all that work if you want.
Box method.
Or you could go straight to what?
Yeah, those are perfect squares of a trinomial.
Yeah, yeah.
Y minus.
Yeah, I was trying to get at, this is like a 1, you can do that little shortcut thing, right? You can go straight to y minus 4, y minus 4, I think is what you're saying, right?
Yeah.
If you recognize it's a perfect square, you can try to do that thing as well. But now we got this thing, we have these 3 sort of factors. They're all equal to 0. So what, or what?
Y = 4. Well, 2 of them.
Don't forget this guy.
3y = 0.
This guy's important. This guy is also important, and this guy is also important. This thing should be giving you y equals
0.
0. This thing should be giving you y equals
4.
yes. Okay. This guy should also give you y equals 4. It is the same thing. So how many solutions were we expecting on this thing? Looking back at here, just like looking at it to start off with, how many solutions are you expecting?
Exponents 3.
Okay, you're expecting 3 solutions. Are you getting your 3 solutions? One, two, three. They're there. But you really only have 2 solutions because this guy is repeating, right? So y equals 0, y equals 4 are our 2 solutions.
Okay, I have a question. So do we only do the equals 0 when we have like a equal sign and not like the other ones?
Yeah, so the other ones you're factoring, right? And so unless we have an equal 0, we're not solving, we're just factoring.
Okay.
And so when we put the equal 0, that's when we're looking for values. That's when we're actually solving things. And again, like looking back at the problem itself, like our original problem has an equal sign in it, right? The factoring ones will not have an equal sign. So this equal sign is telling me that we're solving. Well, also the word solve probably also tells you that you're solving, right? But if they say simplify, that means like factor, probably something along those lines. They would say simplify or factor this, and it would not have an equal sign, right? We can look like all these factoring problems, right? Not a single equal sign in sight. Not until we get to the solving. That's when we're throwing things equal to 0. So I'm really glad you brought that up, because that is like one of the most common mistakes I see, to be honest. It's one of those things like at least 10 other people are probably thinking. Because people will try so hard to make these things equal to 0. And it says it nowhere on there, right? Don't just throw in equal zeros where they don't go. You can set sides equal to 0. That's fine. But don't just like throw in equal signs where they're not there already. Okay. Any other questions?
Well, actually, Mr. Sievers and Mrs. Watson, not really a question, but just a little comment here. I have really tried to get repairs done on my desktop because throughout the last 2 tests, I've been unable to submit them through Lockdown browser after I scanned them from my printer. So if I'm running behind on the submission date, I swear to God, I'm not cheating. I am really just trying to get that thing downloaded through my laptop. So
I don't know. Well, I didn't do the last test, but I thought you submitted that one test on time. I could be wrong.
I remember distinctly.
Timothy, I haven't noticed that you've been submitting super late.
Yeah.
Well, because I know on the last test, I kept count because I've been waiting for the thing to upload, but it ended up didn't happening. I ended up going 30 minutes over the submission time, and I added a little comment apologizing, like I swear, like that, I'm not doing anything funny.
Did you email it as well?
At a time. Sorry.
Just do that. If you'll email it as well, then we'll be
Okay,
good.
yeah, because just wanted to let you guys know.
Thank you.
Thank you very much.
Not doing anything funny like 13 times 7. Is that what it was? That funny math.
Who's on first?
Yeah. It's like, it's really well written for its time.
It
I'm
really.
gonna stop the recording, and if y'all still want to go over more stuff, we can go over more stuff. But I'll be here for